This is Goddess of Science Anatomy, and I'm Mrs. Bolton. Today we're going to talk about different types of joints in the body. That's part 9 of the skeletal system series. Okay, so a joint is just a junction between two bones. Most of the time we think of joints like our knees or our shoulders or our elbows, something like that. But there are other types of joints in the body as well. So, true to anatomy form, there's not just one way to classify these things, there's more than one. And the first way that we're going to talk about is by function, or the amount of mobility that the particular joint has. There are some joints called synarthroses or synarthrosis that are immovable in the body. And a good example of these are the sutures of the skull. You don't want them to be movable because if they move, then they squish the brain that's underneath, and that's never a good sign. Usually synarthrotic joints are used to protect internal organs. There are also amphiarthrotic joints or amphiarthroses, and those are slightly movable. An example would be the pubic symphysis. That's the joint between the two pubic bones in your pelvis, and the intervertebral joints. Add some stability with a little bit of movement, not completely, free range, but a little tiny bit of movement. The third type are diarthrotic joints, which are freely movable, and those are the joints that we normally think about: your elbows, your knees, your shoulders, those kinds of things. There are 3 categories of diarthrotic joints based on the number of axes of movement, number of different directions. If it only moves in a single plane, then it's uniaxial, like your elbow. That really only has motion in one direction or one plane. Biaxial joint has motion in 2 planes, like for example your phalange and your metacarpal. That allows you to tap your finger up and down, but also move your finger side to side. And then you have multiaxial joints that have several planes of motion, like your shoulder and your hip. The other way that we classify joints is by structure. And the first group by structure are fibrous joints. The bones are really, really, really close together with some fibrous connective tissue between them. These are always synarthrotic joints, which means they're not movable. The fibrous connective tissue pretty much keeps everything right where it's supposed to be. So here's an interesting picture of the suture in your head. You have, this is what you see on the surface, but in actuality is very much a 3-dimensional kind of suture. You have this connective tissue that keeps that bone right in place. It's like a 3D puzzle piece. It's not going to slide forward or backwards. It's not going to slide up or down. It's pretty much stuck there. There are 3 types of synarthrotic joints. There are sutures, which we just talked about. Those are in the bones of your skull. There's syndesmosis, and those are kind of interesting. That's the space between 2 bones that is held by a ligament or interosseous membrane. An example of that is the long bones of your forearm and lower leg, and I hope I have a picture. Yes, I do. So this is the tib, as you know, and this is the fib. And the fib is not just stuck to the tib just by the top and the bottom. There's this interosseous membrane between the two, which is that joint is called a syndesmosis. And the last one by structure, here we go, is the gomphosis, which is my favorite one because it's such a great word to say. And that's how your teeth are actually held into your mouth. Because you probably remember when you were a little kid, if you were ever had a loose tooth and you'd wiggle it and wiggle it and wiggle it, and then pretty soon most of the tooth is ready to come out, but there's that little tiny bit of ligament that's left. That is the periodontal ligament, which is the remnants of a gomphotic joint. The reason that your teeth fall out when you're a little kid is the roots start to dissolve. As the new tooth comes up, the root starts to dissolve. So this ligament doesn't have as much to hang on to and your teeth become very, very loose. But only when the signal is given. You don't have to worry about losing your teeth before their time. Okay, so the second type of joint classification by what it's made out of is cartilaginous joints. And as you might guess, there's cartilage involved there. They're held together by cartilage. There's not really any joint cavity in these joints. They're usually amphiarthrosis, which means it has a little tiny bit of mobility, but not like a crap ton. And there are two types of cartilaginous joints. The synchondroses, which are made with hyaline cartilage. An example of that is how your ribs are attached to your sternum. It's the joint between the anterior rib and the costal cartilage and the sternum. So that is where you'd find that. And then you have symphysis, which is made out of a type of cartilage called fibrocartilage, which is much, much more stiff and beefy cartilage. And an example of that is the pubic symphysis. So two types of cartilaginous joints. And there's where you'd find your pubic symphysis. This is when the pelvis is put together. You got your sacrum and your coccyx back here. And you have a joint, sacroiliac joint here. And in the front, we have the pubic symphysis, which is a little pad of fibrocartilage. The third type is probably the most numerous type in your body. They're the synovial joints. And these are the most freely movable joints. They're usually diarthrotic joints or diarthroses. The bone ends are usually covered in this kind of structure. There's a cavity in between. There's articular cartilage there. There's some fluid in between. All kinds of great stuff happening here. So the bone ends are covered in articular cartilage, usually hyaline cartilage. Which you probably remember the bone is actually started out its life as hyaline cartilage. And the whole joint is surrounded by a joint capsule, which is made of fibrous connective tissue. And the lining of that joint capsule actually produces a fluid called synovial fluid. The membrane on the inside there of the joint capsule that lines all of this has is called synovial membrane, and it makes a synovial fluid, which is kind of like the same. It serves the same purpose in your joint as the oil does in your car. If you don't put oil in your car when it needs it, the engine will seize up because there'll be a lot of friction. If you don't have synovial fluid in here in this joint, you're going to have a lot more friction between these two pieces that are rubbing against each other. Oftentimes, as if people have had like athletes that are in sports where their knees really take a pounding, a lot of times, and sometimes just regular people, some of this articular cartilage flakes off or breaks off or rips off, and then it floats around in here, and every now and again it will get stuck in a spot that kind of makes the whole knee seize up. Not a good feeling. So the synovial fluid lubricates the joints just like the oil lubricates the engine in your car. There are 6 types of synovial joints. There's the ball and socket joint, which allows movement in all planes, a rotational kind of thing, like your shoulder and your hip. There's the condyloid joints, which is an oval condyle fits into an elliptical cavity in another bone. Your jaw, your upper jaw, your mandible actually fits into it has the mandibular condyle, which fits into the mandibular fossa on your temporal bone. So that's an example. Gives you movement in different planes, but not any rotation. You know, you can move your jaw up and down and side to some extent, but you can't rotate it around. Another example besides your jaw, your lower jaw hinging, is the metacarpals and the phalanges. A plane joint allows sliding and twisting movements. An example is the carpals or tarsals, clavicle, and the acromion of the scapula. Hinge joint is movement in only one plane, and you probably are pretty familiar with that. That's like your elbow and your knee. Also your phalanges. A pivot joint allows rotation around a central axis. For example, your axis and atlas, those two joints, the atlas pivots around the dens of the axis. Also the proximal ulna and radius. So the radius, remember, has that circle and it allows it to rotate, around the ulna. Also the axis and atlas, as I said. A saddle joint, there's actually only two saddle joints in your body, one location. It allows for a variety of movement. And the only example is in the carpal and metacarpal of your thumb. That's the only place. It's not anything to do with the phalanges. It's the carpal and metacarpal of your thumb. Well, that's it for joints. Thanks for joining me. Have a great day.